Time travel has always been humanity's favorite impossible dream. From ancient myths to modern sci-fi, we've imagined stepping outside the river of time, seeing the future before it arrives, fixing the past before it becomes a scar. But what if time travel isn't as impossible as we think? What if the universe, in its deepest equations and strangest structures, is quietly hinting that time might not be a straight line, but a maze? Tonight, we explore theories that scientists take seriously, ideas so strange they feel like fiction, yet so logical they might just work. 1. The block universe, a timeline already written. Imagine floating above existence, seeing every moment, the dinosaurs, ancient civilizations, your childhood, your death, all laid out like pages in a book. Not moving, not changing, just there. This is the block universe theory, born from Einstein's relativity. To Einstein, time doesn't flow. There is no past disappearing behind us, no future waiting to be born. Instead, every moment exists simultaneously, as real as this one. In such a universe, time travel isn't violating physics. You're simply stepping to a different page in the book you were always part of. 2. Time dilation. The future is already reachable. You don't need a time machine to travel into the future. You just need speed. The faster you move, the slower time moves for you. This isn't sci-fi. It's measured, proven, and tested. Astronauts on the International Space Station come home younger. Not by much milliseconds, but younger nonetheless. Now push this idea further. If you could ride a spacecraft at 99.9% the speed of light, a few years for you could be hundreds of years on Earth. A one-way trip to the future is not only possible, it's already happening. We just can't control it yet. 3. Wormholes, tunnels through time. Picture space as a sheet of paper. Now bend it. Touch two distant points together. A shortcut appears. This is the concept of a wormhole, a tunnel connecting two separate locations in space-time. But here's where it gets crazier. If one end of the wormhole experiences time differently, say, by moving at near light speeds, the two ends become out of sync. Step into one end, and you don't just move across space, you move across time. It's not a fantasy, the math is there. The universe just hasn't revealed whether it actually allows one to exist long enough to walk through. 4. The many worlds interpretation. No more paradoxes. You know the classic paradox. If you travel back in time and stop your own birth, how can you exist to do it? The many worlds interpretation simply says, don't worry about it. In this theory, every choice, every event, and every possibility creates a new universe. Go back in time and change something? You haven't altered your timeline. You've branched into a new one. No paradox, no problems, just infinite histories waiting for footsteps. Time travel becomes less like editing a film and more like switching channels. 5. Cosmic strings. Wires of the early universe. Cosmic strings are theoretical, but if they exist, they're among the strangest objects in the cosmos. Imagine a strand thinner than a proton, but heavier than a galaxy. A fault line in space-time itself. If two of these strings passed each other at high speed, they could twist space-time so violently that time loops would form around them. Fly the right path around them, and you might find yourself arriving before you left. This is time travel by surfing the scars of creation itself. 6. The Tipler cylinder. A machine to bend reality picture. A cylinder enormously long spinning so fast that space-time curls around it like water down a drain. According to physicist Frank Tipler, such a rotating giant would create a closed, time-like curve. In other words, a loop in time. Travel around the cylinder, and you arrive in your own past. There's only one problem. To build it, you'd need infinite mass, or a cylinder infinitely long. Buildable? Not yet. Physically possible? According to the equations, yes. 7. Quantum tunneling. When particles cheat the rules, on the quantum level, particles don't behave. They vanish from one place and reappear in another instantly as if they jump through time, space itself. Some scientists believe this hints that time isn't smooth and continuous, but grainy and glitchy, like pixels in a video. If so, time might have shortcuts hidden in its fabric. Shortcuts particles already use. We just don't know how. Yet. 8. Simulation theory. What if time is just code? If our universe is a simulation not proven, but taken seriously by many thinkers, then time is simply a variable. It can be paused, rewound, edited, not by machines of metal, but by whoever holds the source code. Time travel becomes not a question of physics, but permissions. So, is time travel possible? Every theory we've explored tonight is grounded in real physics, real math, real questions scientists still wrestle with. Is time travel easy? No. Is it allowed? Maybe. But here's the truth. The universe is stranger, deeper, and more flexible than we ever imagined. And in its darkest corners, in its strangest equations, lies a whisper. Time might not be a barrier, just a direction. And directions can be changed.